There is a reaction that has 2NO gas plus O2 gas goes to 2NO2 gas. The delta G of this reaction is negative 66.4 kilojoules. The delta S for this reaction is negative 146.5. And we can assume that it's negative, the temperature right now is 326 kilojoules and 1 atm. So this equation asks us two problems, or to figure out two things. So it says this reaction is either reactant or product favored under standard conditions at 326 Kelvin. The standard enthalpy change for the reaction of 2.13 moles of NO gas at this temperature would be blank kilojoules. So since the delta G is negative, we can assume that this is going to be product favored. So it's going to be a product favored. And then to figure out this, we can use this equation, which is a delta G equals the delta H minus the temperature. Oh my God. And the delta S of the formation, which we can rearrange to solve for the H, because since we were given the G and the S, we already know those, so that then we can solve for the variable that way. So then we can plug that into the equation. And we want to make sure our units are accurate here, because since S is in joules and G is in kilojoules, that will change our answer. So I already put S into kilojoules by dividing the negative 146.5 divided by 1,000. So then when you plug that all in, you get negative 144.2 kilojoules. And then what you can do is to solve for the standard enthalpy change, you can take the number 2.13 moles of NO, which is what they gave you. You can times that by the number you found here divided by 2, and that will equal negative 122 kilojoules.